All right, this is Chris here, and what I'm going to show you is how to set up your Eclipse workspace and the Eclipse IDE so that you can run your programs for Comp 15 this semester through the Eclipse IDE. What's nice about Eclipse, as I mentioned in class, was that it allows you to do debugging and have all of your files in one place at one time, and it makes it a lot easier to deal with than trying to use Vim or Emacs or some other editors and kind of having the files all over the place. You'll see what I mean when I get into the demonstration. But what I'm going to do is I'm going to set it up so that you can use the files straight from the homework server. And what that means is that we're going to run Eclipse on the homework server, and it's going to be through the internet, and all of your files are going to be kind of locally on the homework server so that you can get to them. What that means is that we're going to have to actually SSH into the homework server, and I will demonstrate that. I'm actually on a Mac myself, and if you happen to be on a Mac, you can do this using just a terminal, and you may have to install what's called Xquartz or X11. And what that is it allows the homework server to kind of push you the windows for the programs that you're going to run, in this case Eclipse. You can also set it up using, there's a similar X11 server for Windows. And I'll put information about that on the class website. So here's what I have. What I'm first going to do is, I'm actually on my Mac at work, and what I'm going to do is SSH into the homework server. Oops, I forgot. I have to do SSH-X, which means X forwarding, which will allow it to push the information with the windows to you. Homework.cs.tufts.edu. Okay, and I've got it set up so that I don't actually have to type a password when I SSH. You can do that. It's actually pretty secure. If you want, you can figure out how to do that, but you may have to type your password if you do that. But what I'm going to do is, first things first, I actually created a folder called Comp 15. Some of you I know like to put these things on your desktop. Whatever you want, it doesn't really matter. But in Comp 15, I'm going to create a directory, and in this case, I'm going to call it pointer test. All right, and we're going to make a directory called pointer test, and then I'm going to change into that directory. Okay, and then the directory is empty. And what I'm going to do is I'm going to copy the files. Now, the command I'm going to use, the cp command, is going to be slightly different than the one that you will use yourself. I'm doing this during the summer, and the website isn't set up, so the actual command will be slightly different, but more or less the same idea. In fact, it'll be the same from here on, public HTML, and files, pointer math, I called it pointer math there, and we're going to copy all those files into the directory here. Let's see, omitting directory. Oh, do all the files, star, dot dash. Okay, now what I've done is I've copied all the files into, this is, by the way, is the command. It's going to be slightly different, and I'll have that on the website. And what I do is I've copied all the files on here. You'll notice there's three files you may recognize: main.cpp, pointermath.cpp, and pointermath.h. And there's another file in here called a make file. The make file, if we actually take a look at the make file, what that is a, it starts up here and it goes on here, and that actually, it's a little script that says, hey, here's how I compile this project. And I will provide you make files so that you can do the providing for class. If you don't know what that is, don't worry about it. We'll figure that out pretty quickly, but that actually allows you to submit the homework. That actually submits it. And this will actually do all the compiling for you. What's nice about a make file is that it makes it so that you can compile files very quickly, and you don't have to always do all these really long commands. It's all in the make file. Eclipse will, as it turns out, create its own make files for you. So you won't actually use this right now. But at the end of the little demo here, I'll show you how we're going to use that and how you can compile it yourself. Okay, so what I've done, I've got the files in here, and what I'm going to do is I'm going to start up Eclipse. I'm going to start Eclipse, then I'm going to type a little ampersand, and that will give me allow me to go back to my terminal if we need to. And what it's doing is it's saying run Eclipse in the background. So Eclipse will come up and it will put up this little splash screen and then say, hey, select a workspace. You can generally just click OK. It'll probably select a workspace in your main home directory. And you can click this to, it'll never ask you again if you click that. And you can just click OK, and it'll do a little more thinking and then come up with this window. Now, in here, you've got a number of things. You've got a Project Explorer side. This will have all your projects in it. And down here, it'll have a bunch of messages. The code will be up here. And there's a bunch of buttons here that allows you to make the files and debug them and so forth. We'll get into some of that. Okay, over here, you may not have both of these. If you drag this little thing back and forth, you should have a debug and a C++ window there. We're going to be spending most of the time in the C++ window. Okay, all right. So, by the way, there may be a little bit of lag on the system here. If you're running this from your dorm, or if you're running especially from off campus, you may have a bit of a lag, and it may be hard to work with from the homework server. You can install Eclipse directly onto your own computer. It's a little more work, but then you can do it locally and have it so that you don't have to have an internet connection up and running. But for now, I'm going to show it to you here. And if you're on campus, it should be relatively fast without much lag. Okay, but here's what we're going to do. We are going to create actually, the first thing we're going to do is set up the preferences for kind of your global preferences. You should only have to do this once. And what we're going to do is we're going to set up the preferences. You go to Window and then Preferences. And there are a zillion preferences here. It doesn't look like there's that many, but each one of these little things goes down. For instance, we're going to go to General, and then you'll see there's a zillion things here. And then we're going to go to Editors. And you can actually make this a little bigger so you can see some of these, although it changes the window size. Let me pull that up here. There we go. All right. And then, so we're going to have General and then Editors, and then we are going to go to Text Editors. And I'm going to set up some things that I think you should have set up so that it makes your life a little bit easier here. And then, actually, we don't need to click. Let's look on that. We're just going to click directly on Text Editors. Okay, first things first, tab width. You can have it set whatever you want, but I suggest a tab width of 8. Makes it easier to see what's on the screen, and it makes it easier to read where functions are defined and so forth. So I suggest that. You should also definitely click on Show Print Margin. It will probably be unclicked when you go through this the first time. And it should be 80. Now, what this means is as you go across a line, you'll get to 80 characters, and there'll be a line there that says, that shows that you're going over 80 characters. We will actually take points off of your assignments if you go over 80 characters. Why? It's so that we can grade it easier, so you can see things easier on a smaller screen, and the way we have the grading set up makes it easier to have it limited to 80, so don't go over 80. So that's why you want this. You should also click Show Line Numbers. That makes it easier to debug when it says this is such and such happens in the line number, whatever. You can go right to it. Okay? All right, so that's that. Make sure all those are clicked. Okay, and next thing we're going to want to do, and this is kind of related to the tabs again, you're going to go down to C++, you're going to expand this and go down to Code Style. Okay, I have already set this up. You're probably going to have it such that it says K and R built in, and what you're going to do is you're going to go to Edit this, and same thing, you're going to change the tab size to 8. Okay, then you're going to click Apply, and actually, sorry, you do have to change the name, something like 8 tabs, doesn't actually matter. Then you're going to click Apply and then OK, and then it will say this and it will be all set up for you, okay, with the 8 tabs. All right, and that's it for the overall. You're going to hit Apply and then OK, and that's it for the overall settings. All right, now let me show you how to set up a new project. Come over here and you click File and then New C++ Project. Bring up a window here, and you're going to have to type the name of the project. Now you have to be really careful here. You cannot type the same name as the folder you created. It's a bug in Eclipse. I don't know exactly why, but in this case I'll type pointer math, and then I always put on a little underscore project here to say it's going to be different than what I have. Okay, so pointer math project is going to be the name of my project. We're going to use the default location. That is actually perfectly fine. And down here, we're going to click on empty project and then Linux GCC. Okay, and then click next. Don't click finish because we need to do some more setup. Click next. Okay, and you'll notice there's a couple configurations here. We're probably going to spend 99% of the time in the debug one, but we'll set both up anyway. And you then click advanced settings. Now again, this is for the project settings, and there are a million of them. Actually, it's not quite as many, but there's enough to get a little confused if you don't follow along. Another bug in Eclipse that I found means that we have to do this in a particular order. And that order happens to be, first things first, we're going to click on C++ General, and then underneath that, we've got to do the little triangle, and then underneath that, we are going to click on, let's see, paths and symbols. Okay, and over here, we're going to set the source location. And what we're doing now is we're actually loading in the files that we copied, so we don't have to like manually copy them. Okay, what you're going to do is click link folder. First of all, make sure this says debug active. That's another bug that I think it has to say that anyway. At least I think it does. And click on link folder, not add folder, but link folder. Okay, you're going to click on link folder, and then we're going to click on this little box here that says link to folder in the file system. And then we're going to browse for it. And in here, it may come up with the file already, but if it doesn't, find where you put the folder. I happen to put the folder pointer test. Okay, and click OK. All right, and then click OK again, and it will put it up right there. Okay, and that's the first thing. Then we can click Apply. Now this is the next thing we have to do. We now go up to where it is C build, and what we're doing is we're using the Clang compiler. We actually go down to C build and then settings. Right now, you guys may be used to using G++. We're actually going to use what's called Clang++, which is I consider it a better compiler. It actually gives you nicer error messages, and overall it's pretty good, but we have to change that. I forgot, we should first go to all configurations here. Okay, change Gcc C compiler to Clang++. You can also change the Gcc C compiler to just Clang. That probably won't actually get used, but you can do that. And then down here, change the Gcc C++ linker also to Clang++. Okay, and click Apply, and then click OK. Can't see the window here. There it is. Click OK, and now you can click Finish. Okay, now what we've done is we've created this project called this Pointer Math Project, and if you click on the little arrow here, you'll see there's a bunch of included files, and then, oh, look, there's our folder that we included, and all the files that are in there, okay? Eclipse will actually ignore this make file, but the rest of the files here are, you can just double click on them and they'll come up like this, and if I click on pointermath.cpp, it puts it here, and then pointermath.h. What's nice is that all of these files are right here, and you can go back from one to the other, and it will makes it real easy to go from one back to the other and back to the other. Okay, so what I've done is I've come up with just a little test project here, and all it does is it does a little bit of pointer math, and I created a silly little class to do that. And for the .h file, you can see the class is very straightforward. Pointer math, there's a constructor, there's a destructor, there's a couple functions here to append a value. We're basically creating an array and appending the value to the array. And then we're deleting, and then I have a little function that will reverse the array, and then one that prints out the array. Okay, and then some private variables and so forth. You can take your time looking through this if you want. And what we can do is, the first thing we can do is we can actually test to see if it builds. Okay, this little hammer over here is for building. Okay, what it says is build debug for project pointer math. That's exactly what we want to do. So I'm going to click on that, and what it'll do is it'll start compiling it with C++, with Clang, and down here there will be the all of the files here. Now, let me see. There's a couple issues here. First of all, why that has that in there. We're just going to type pointer math .h. That is a bug right there. Okay, let me try to debug it. Let me try to build it again and see what happens. Aha! Now there's all sorts of errors. Okay, this is purposeful, by the way. Okay, so what happens if you go down here and you go, oh my god, look at all these errors. Well, what you can do, what's nice is, you can say, okay, well, let's see, error use of undeclared identifier I for I equals 0. I don't know, that looks pretty, I mean, it looks okay to me. What we can do is just double click on this and it will take you right there. Haha, that's very nice, right? And then you look around here and you go, okay, well, let's see, I've declared temp. Oh, I didn't declare I, you're right. Well, I can do that like this. I can do it a couple different ways, but why don't we just do it this, like that? Okay, now I've declared I. Sometimes Eclipse will be smart enough to say, oh, you fixed whatever the problem was and take all those out. But all we need to do now, since we fixed that, let's go back and click build again. And you'll notice it did all the building and no errors, right? It says finished building. I don't see any errors. That's fantastic. And it is using Clang++ and so forth. Okay. All right. Well, what that means we can do now is we can actually run it. Before we do that, let's just see what it's going to do. Okay. The program actually, in the main function, it says creates a pointer math class variable and using the default constructor, and then it fills in the arrays with values 0 to 9 by appending the values. Again, you can look at this in slower at your leisure. And then it prints out the array, and then it reverses the array, and it prints it out again. Okay? All right. So how do you test if it's working? Well, there's two different ways you can do it. The easiest way is this little run button. You can also actually hold down the run button, and then when you release it, if you hit the little the arrow down there, you can say run as it should run it automatically. And I believe you can also do it, here we go, you can also do it with the run button up here, Control F11, depending on the way your keyboard's set up, that'll work, and sometimes that won't. And that's it. So anyway, we want to click this and see if it works. Okay, and it runs it and says some things, and then boom, here's the output. Now notice, the output is right in the same window, which is great. Okay, no more fooling around with the terminal and seeing what the terminal says. This is kind of a double-edged sword in that sometimes it's not as easy to handle as the terminal, but it's right here, and there's the output. Okay, now let's see what it did. All right, we said that we were filling in the array with values 0 to 9, and then we printed it out, and then we reversed it, and then we printed it again. So printed 0 to 9. So it looks like that actually worked correctly, 0 to 9. And then reversing it. Well, our reverse is a little screwed up, right? It looks like it put some big number here, then it reversed the rest of it, but then 0 is missing, and so we've got an issue here. Now, there's a couple different things you can do. You could certainly go to the reverse function, right? And you could figure out and debug what's going on here, and feel free to do that if you want a little bit of a challenge. It's not too challenging, as it turns out. But what we can do is I wanted to show you this. This is a bug in the program. I want to show you how we might actually debug it. Okay, so let's do this. What we can do is we can say, all right, I know that I'm going to go look at what's actually going on in this reverse function. Okay, I want to see it while it's running. I want to debug it in real time. Okay, so what you can do is you could actually, let's say, I think, well, it looks like maybe the reverse function's wrong, so I'm going to say I want to look at this little section. What I can do is if I double click right on the number there, line 38, see that little dot right there? That means that it's set a breakpoint. And that says I'm going to run the program and then stop when I get to that line. Okay, and that's kind of cool. So you stop when you get to that line. All right, how do you do that? Well, this little bug up here stands for the debugger. If you hold down that button, you can show how to debug it. But all you need to do is actually just click on that little guy, and what will happen is it will come up and it will start to run, and then it says some things here. Don't worry about what's happening down in the console right now, but it says this kind of launch is configured to open the debug perspective, and you do want to do that. And I'll show you why in a minute. But you can click this. You can also click Remember My Decision, and then it'll never ask you again. But what happens is it switches to a different form of the window here, and it's got lots of information in it. Okay, and what it's done is it actually has started the program and has gone to the first line in the program. Okay, you can actually set it up. I'm not going to go through how to do that here, but you can set it up to just go straight to your first breakpoint. But what it normally does is it starts and it goes to the first line and says, what next? Okay, and it has started running. Now, notice something here. There's a window here that has a whole bunch of like crazy stuff in it, but it's basically saying what I'm running, and it will tell you where in the program you are. In other words, it'll tell you what functions you're in, and you can back up and go forward, and it's pretty cool when you get down into it a little bit. This will be very, very helpful when you need to start debugging pointers. Okay, so let's actually do this. There's a couple buttons up here. This one says resume. Just in other words, continue running the program until I get to my next breakpoint. This one says I'm done, stop. Okay, there's a couple other ones that are important here. There's a step into button. That is useful when you are about to go into a function and you want to actually go into that function, okay, and go to the next line inside that function. That means this says step into the function. This one is step over the function. In other words, if I'm about to run a function and I click the step over, it will go into the function, run everything in there, and then stop after that function has been run. A lot of times you don't want to do that because you kind of want to do dig in, but sometimes you do. You say, okay, I know this function works, I want to step over it. Then you can also go into instruction stepping mode, which is much more detailed, and you're probably not going to want to do that. So in this case, what we're going to do is we're going to click resume. What that is going to do, that is going to take us and keep running, and notice, I know the window gets a little small in here. In fact, I can make it a little bigger by doing this. Okay, what it's done is it says, hey, I've run the program and now I'm inside the reversal program, and notice it did the first thing. It inserted all the numbers and then printed out the first thing, which we wanted to do, and then now it's doing the reverse. Okay, what's cool is up here, this tells you all about what's going on. Okay, it says in this function there's a variable called temp, right, which I created. There's a variable called I, which we created. Okay, temp happens to be, they're both kind of dummy values right at the moment, but that's that. And then it's about to go into this little for loop. Okay, you also can go, this is like the bigger program in general, right? And I'm sorry, the actual class in general. And this is kind of cool because this shows you the array, right? And it'll show you, it'll actually show you the details of the array. The way I've done the array with the pointer math, unfortunately, it won't show you all the values. You can actually change it to do that. I'll have to look up how to do that because I forget exactly how to do that. But for now, it will show you exactly what's at the array at the beginning of the array, which is 0. Okay, and we're going to go from there now. Actually, I do want to try this. Let's see, cast to type, display as an array. Aha, start index 0, length of 10, and aha, there we go. What this will actually tell you is what's at all the different parts of the array. Oh, nothing is in the array yet. This is too bad. I was hoping it would show you what's in each little section, and it did not. Well, without spending too much more time here, yeah, it must be a bug in the program. That's too bad because it would be very helpful if it did that. Let's see, maybe. Oh, there we go. Yeah, I had clicked on the wrong. I guess I had clicked on the wrong thing. So here we go. Now, what it's showing us here is the array and values 0 through 9. Okay, and it says the size of the array is 10, and those are our private variables, incidentally, from the class itself. Okay, I'll hide that for right now. Okay, so let's start going through the array. How we're going to do that? We're going to use step over. It doesn't really matter in this case. Step into or step over is fine. What it does is it says, okay, step into the array, and I click that, and notice it changed. It normally is pretty nice about highlighting what it's changed. It highlights at least a few of the things that it's changed. So in this case, it says, look, I made I equal to 0. Okay, temp is still some dummy value right now. If I click step over again, temp now gets set to what is at array plus I. Now remember, array 0 is 0, so temp is actually set to 0. Okay, what I'm saying is set what's at location 0, this is the pointer math part of it, to what is at the array plus the size, and size, by the way, look, by the way, I can highlight this, and it tells me what size is. Size is 10. Size minus 1, or minus I. I is 0. So what this is going to do is it's going to say, whatever is at 0, because I is 0, gets what is at the array at the location size minus 0. And if we do another step over, we can say, oh, okay, well, what went into array plus I? Bogus number went in there. Why? Well, this is where the debugging part comes. Now you know, hey, there's where my bogus number came from. What's the issue? And without leaving or without too much suspense, here's what the issue was. What I had done is, because size is actually the number of values and arrays are 0 based, we actually have an off by 1 error. So really what we need to do is size minus I minus 1. We can change it right here, by the way. We do have to recompile if we want it to run again, but size minus I minus 1, and that should actually solve our problem. Okay. Now we can keep running this, and it'll keep doing it. It'll do the it will do the last. It's not doing the new stuff that we just changed, but we just fixed the error. So what we can do is we can terminate it. We can actually go back into. We could do a couple things. We could just run it again, right? And you can run it right here, and it'll ask if you want to save the changes, and then you run it right there, and it'll run it, and looks like we fixed the error. Okay. So that's how you do the debugging. I'll go back to the C++ and you can do that. Now, all of that is how you set it up. Now what you've got is this project. You can continue to work on the project. You can add other files and things. I mean, if you want to add a new class, it will add both the .cpp and the .h file for you. You can do a class, or you can just do a source file if you want another file. Most of the time for our projects, you won't have to do that. But anyway, you can do all the debugging, you can do all the testing, all the details come right down here. Okay, now the last thing I want to show you, and by the way, you can do a couple different things. When you are done with the project, you can actually go to Project, Close Project, and then it won't try to run that project next time you open another one. Let's say you wanted to open the project, you would just open it, and you get it back to the running mode again, and so forth. Okay, now let's say you've completed your homework, you're all done with it. You want to exit, and okay, looks like it had some error when it exited, but too bad. Okay, now you've got all of your files. Now, these are the ones we changed. Okay, I mean, we can actually look and see if this is what we changed in our .cpp file. Let's see. Reverse. Yep. See, so right here we said array plus size minus I minus 1, minus I minus 1. So we had fixed it. So it puts all the files have been changed and they're here. Now what we can do is we can actually run it again using make, and that actually runs this clang file and puts the actual file here, so you can run it here, kind of the way you normally might run it from the command line. Pointer math, and there we go. Okay, and then finally, in order to provide, you're just going to type make provide, and I can actually do it. It won't work because I haven't set up the provide yet, but what it'll do, yeah, it's giving me a provide error, but basically that's all you have to do for to provide this when you want the homework to be graded. Okay, all right, so hopefully that has given you a bit of information on how to go about setting up Eclipse, and we can talk more about it in lab or in class, and if you do have questions, feel free to email me. Thanks.